Have you ever wanted to explore the red planet? Take a journey to a distant world and discover the wonders beneath its dusty surface? If so, then you must take a look at the volcanoes of Mars. Mars is home to some of the most spectacular volcanoes in the solar system, and this visual guide will take you on a journey to explore them. From Olympus Mons to Tharsis Montes, these grand and imposing volcanoes offer a fascinating glimpse into the history and evolution of the red planet. Whether you're a budding astronomer, a seasoned space traveler, or just curious about the mysteries of the universe, this video will provide an exciting and informative exploration of Mars volcanoes. And what would happen if these same volcanoes existed on Earth? Make sure to stick till the end of this video as we have a lot to cover. Let's dive right in. The volcanoes of Mars are a critical part of the planet's history, and their formation and evolution are believed to be directly related to the development of the Martian atmosphere. Mars was likely very similar to Mercury, which has no atmosphere and is covered in crusted lava and dust. As the planet aged and cooled, a crust formed, and the interiors of the planet solidified. As the Martian interior cooled, the planet's core slowly solidified, and the immense pressure within the planet's interior slowly decreased. The decreased pressure allowed a portion of the planet's mantle to rise above the surface and create volcanoes. These volcanoes created an atmosphere around the planet and cooled the core by releasing large amounts of thermal energy. So let's start with Olympus Mons, the largest volcano in the solar system. Olympus Mons is a genuinely remarkable feature on a planet full of remarkable features. As the largest volcano in the solar system, it stands an impressive 16 miles high and is over 600 miles wide at its base. It is so immense that if you remove all other volcanoes in the solar system, Olympus Mons will stand on its own as the tallest mountain in the entire solar system. With a name that means Mount Olympus in Latin, it is no surprise that this enormous volcano is the centerpiece of the Tharsis region of Mars. Olympus Mons is a shield volcano first identified in the 19th century. Shield volcanoes are standard on Earth and are named for their profile's broad, flat shape. Though they are not as visually impressive as other types of volcanoes, they can build enormous mountains as they slowly push through continental crust. On Mars, shield volcanoes are found only in the Tharsis region, where they are the most massive and oldest volcanoes on the planet. Tharsis Montes is another massive shield volcano within the Tharsis region of Mars. While it is slightly smaller than Olympus Mons, it is often overlooked because it is covered by later literal lava flows. These flows have covered Tharsis' central peaks and have given rise to a more even, plateaus-like surface. Though it is not as spectacular as other regional volcanoes, it is a critical piece of Martian geology. It has helped shape the planet's ancient history just as other volcanoes of the Tharsis region have done. There is evidence that volcanism in the Tharsis region is waning. The other volcanoes are much younger than Olympus Mons, and the largest among them, Tharsis Montes, is thought to be less than 2 billion years old. This would make it one of the youngest volcanoes in the solar system. Tharsis Montes is a string of shield volcanoes associated with the giant Olympus Mons. They form a fantastic ring around the northern hemisphere of the red planet. They include the three largest volcanoes in the solar system: Tharsis, Pavonis, and Tharsis Montes. The Tharsis Montes are enormous volcanoes that dwarf the volcanoes on Earth. These shield volcanoes are at their base tens of miles high and hundreds of miles wide. They are far younger than any other volcanoes on Mars, with ranges ranging from 1 billion to less than 100 million years old. Tharsis Montes is a shield volcano within the Tharsis region of Mars. This massive volcano is the oldest in the Tharsis region, forming about 3.5 billion years ago. It is the only ancient volcano on Mars and is only one of a few shield volcanoes in the entire solar system. Unlike other volcanoes in the Tharsis region, Tharsis Montes was formed when Mars was a much more active planet. As the most ancient volcano on Mars, Tharsis Montes has been heavily eroded by the Martian wind, leaving a broad and nearly featureless plain at its summit. The gentle slope is caused by the shallow gravity of Mars, which allows the wind to flow much more freely than it does on Earth. The volcano's surface is covered in a layer of fine dust, which gives it the orange tint visible in the images taken by spacecraft orbiting Mars. Let's take a look at Olympus Mons, the red planet's youngest volcano. Olympus Mons is a very young volcano on Mars with an age of only 1 to 2 billion years. This is a very recent event in the red planet's lifetime, indicating that volcanism is still taking place on Mars. This is surprising as Mars is much less geologically active than Earth and consists mainly of a cold and frozen desert. Olympus Mons is a shield volcano like many other Mars volcanoes. It is the youngest of all the volcanoes in the solar system and indicates that Mars is still an active planet. It is unclear why the volcanism on Mars is still relatively active, and Martian scientists are trying to figure it out. Olympus Mons is the second youngest volcano in the Tharsis region, formed less than 1 billion years ago. It is much smaller than the other volcanoes in the Tharsis region, with a height of only 6 miles. It is also a shield volcano, like the rest of the Tharsis volcanoes, though it is far smaller and more subdued than its massive neighbors. Olympus Mons is a critical piece of Martian geology because it is the only volcano in the Tharsis region not associated with the Olympus Mons volcanic system. This means that the eruption of Olympus did not occur above a mantle plain, which has been the source of most of the other Martian volcanism. So you might have been wondering what would happen if these volcanoes existed on Earth. If earthly volcanoes cause so much destruction, then what would be the effects of Martian volcanoes exploding? The results would honestly not be pretty. Although no one has ever witnessed a Mars volcano erupt, scientists may nevertheless perform calculations and make predictions based on the outcomes of previous eruptions. For instance, Martian basalt volcanoes have the potential to release large amounts of volcanic ash in plumes that travel great distances. Over a large area, the ash would resurface and deposit layers of loosely packed material. On the other hand, the erupting column may collapse and cause the vent at ground level to erupt with a superheated cloud of ash and gases. A deposit of pyroclastic debris would remain when this mixture has cooled. On Earth, silica-rich magmas rather than basaltic ones are the primary source of these eruptions. However, because of Mars' lower gravity, these catastrophic eruptions would occur more frequently. Volcanic eruptions on Earth would significantly warm the planet. In addition, sulfur dioxide gas produced by the volcanoes would have a large greenhouse effect. According to the research team's computer simulations of the early Martian atmosphere, volcanic eruptions would generally heat Mars' equatorial area to a temperature where water could flow. Sulfuric acid may not have cooled Mars as much, though, because the atmosphere of Mars is dustier than that of Earth. Normally, this dust reflects sunlight, keeping the red planet cold. This dust would be coated in sulfuric acid from volcanic eruptions, which would make it reflective but would reflect sunlight less than sulfuric acid and normal dust particles alone, according to researchers. The Martian volcanoes are genuinely some of the most fascinating features of the red planet. They show the evolution of planetary bodies and the effect of planetary cooling. They also show the impressive power of plate tectonics, which is crucial to keep a planet habitable. The Martian volcanoes may also provide answers for how Mars was formed and became the arid desert we see today. With the technology available, we can see the volcanoes in much more detail than ever. We can get much higher resolution images and study the gases in the Martian atmosphere. With these new tools, we can make strides towards understanding the evolution of Mars and the formation of our solar system. Make sure to let us know your thoughts down below. Subscribe to the channel as a sacrifice to the gods of the algorithm. Thanks for watching.